Hello everyone, welcome to this webinar which would talk about, which would be a deep dive session of one of our application templates, basically a one-way HDFS to HDFS sync. This topic will be taken up by our engineer at DataTorrent and also a committer at Apache Apex, Mr. Yogi Devendra. Thank you all for your participation in today's webinar. This session is being recorded and the video would be available at the end of this particular session, and the slide decks would be shared at SlideShare. So I would now hand it over to Yogi.
Hello everyone. So today's topic for discussion is about HDFS to HDFS sync app template. So we will go into the details of this app template. But just before that, I would like to introduce about Apache Apex project, and just briefly we will explain about what is the ingestion problem and challenges faced in big data ingestion, and then we will move on to the actual app template and details about HDFS to HDFS sync app template. And at the end I will show the demo, and then we can see how the scalability and fault tolerance is handled in this particular app template. So let's start. So Apache Apex is a runtime engine, and it basically allows you to develop big data applications which are scalable and fault tolerant. And this platform is a Hadoop native platform, so if you have Yarn and HDFS in your cluster, you can use Apache Apex to build streaming applications. This is a unified engine, so it can process streaming data as well as batch data. So you can process data at rest as well as data in motion. And applications developed on top of Apache Apex have characteristics of low latency and high throughput. So in the actual customer use cases, we have even seen the latencies of up to few milliseconds latencies. So even the single digit millisecond latencies have been achieved using this platform. And along with this Apache Apex platform, we have a bundle of commonly used functionality which we call as Apex Malhar library.
I think the screen is not visible. Hello everyone. Could people just confirm whether our screen is visible to everyone? I guess there are some questions. Some people are not able to see the screen. Could people just confirm that? Okay, I guess it's visible to most of them. So some people might be having some difficulty at their end. So we'll continue. Thanks, Yogi.
Okay, thank you. Yeah, so we have a library of operators, which is Apex Malhar library, which bundles the commonly needed business logic. So for example, if you are connecting to, let's say, some file system or some databases or things like Kafka and so on, so you will get ready-made connectors for those things. As well as you can write your custom business logic in your applications, and for that you don't have to learn any new paradigm as such. You can write simple Java code, so any developer can, there is very little learning curve involved. So when we talk about big data projects, generally what we observe is, many of the projects reach to the POC state, and very few of them actually go to the production. And the reason behind that could be because there is no enough expertise within the team to handle the scale of big data, or the platform itself is not maintaining the backward compatibility. And there could be some SLAs from the requirement side, and finally you observe that platform is not able to meet that scale and maintain that SLAs and so on, or it could not meet the peak requirements I mean, if the platform is not supporting dynamic scaling, then it's difficult to meet the peak requirements. So basically, we need a platform which takes care of these things, and it eases out the burden on the app developers to develop big data applications. And this is actually the rationale behind the Apex platform. So if we look at the overall big data ecosystem, there are many such projects in the ecosystem. But why do we have yet another project which is doing the same thing? The main reason is we are more focused on time to market and reducing the burden on app developers. So we want to migrate a lot more use cases to Hadoop, and we want to reduce the time to market. If you want to have a look, you can refer to this wiki page for the Apex proposal. So guiding principles for Apache Apex projects, the first and most important thing is operability. So if we look at the big data project requirements, generally the functional aspect is only 20%. It could say that, okay, I want to read from Kafka and write to HDFS. The 80% of the crux of the project lies in the operational part. How do I scale? How do I take care of the changes in the configuration and stuff like that? So we want platform which takes care of these things, and Apache Apex is very much focused towards operability. Definitely, it's a highly scalable and performant platform. Fault tolerance is taken care of by the platform, so app developers doesn't have to write any boilerplate code for handling fault tolerance. It's a Hadoop native platform, so if you have Hadoop cluster in your organization, you can use Apache Apex on top of it to write the big data applications. There is no need to set up a separate cluster as such. It's very easy to integrate with third-party components and easy to develop because you can write your code in core Java. Okay, so use cases are from different domain. It could be advertising, like processing the ad clicks, or it could be processing sensor data like IoT domain, or it could be fraud detection systems in the finance domain, or processing CDR records in telecom domain, or simply the ingestion like ingest the log files and do some transformations on it, do some ETL kind of stuff. So there are various use cases. So typically the pipeline would be to read from some source, then do some custom processing using Apache Apex, and then write to the store of your choice. So overall, this is how the architecture look like. So at the bottom we have either physical machines or cloud or virtual machines. On top of it, you install Hadoop, so it could be any distribution of your choice. And on top of Hadoop, basically we use Yarn and HDFS services from Hadoop. So on top of it, we have Apex runtime engine. So this particular component which you see, streaming runtime engine. So your applications run on top of this runtime engine. So you can think of it as OS for your streaming applications, and each streaming application will run on top of this. And we have a library of open source operators, which is Apex Mallar, and then the custom applications built by the app developers, or even the app templates developed by DataTorrent. So on top of Apache Apex, which is open sourced under Apache, we have a proprietary RTS release, which is real-time streaming engine. And as a part of DataTorrent RTS, you will get graphical application, which is like a drag and drop tool for building your applications. You will get data visualization dashboard, as well as the management console, which is like the most critical part. You want to see like what containers are failing. If you want to look at the logs for the for debugging and stuff like that. And yeah, we have REST APIs. If you want to, write your own tools for management, you can use REST APIs for communicating with the Apex engine. Let's move on. So, any question till now? Okay, so there are no major questions as such. Let's move on to the next topic. So, let's look at in brief what is ingestion. So, ingestion basically has everyone have their own definition for ingestion. But in general, if you look at, generally people agree that it's about obtaining data, importing it, processing the data for later use, and store it in some store. So it could be database or NoSQL store or HDFS or stuff like that. So when we look at big data ingestion, it also covers discovering the data sources. So we might want to look at, okay, what all new files have come in this particular directory. Or it could be like if you are reading from Kafka, you might want to look at what are the new messages coming into it. Then importing the data, whatever new data comes in, you want to take that data, then do some transformation or processing on that data and produce some intermediate data. And finally, you get some final results, which are like the summary, which you want to store for later use. Okay. So when we take this ingestion problem at scale, the typical challenges are basically the failure from recovery. So if you have, let's say, if you want to copy 1 terabyte of data, and after copying, let's say, 100 GB, the job failed. We don't want to start all over again, right? We want to start from where we left. Then specifically, if we are talking about, let's say, file copy application, we want that application to handle large number of files as well as copying big files in parallel. So for example, if I have a single big file which is, let's say, 100 GB, I don't want a single container to copy that file. I would rather expect my engine to split that file, and each split is taken care of independently. As well as we want to have some bandwidth limit, in a sense that suppose your cluster has some resources like the network resource or memory resource. You want to constrain your application in such a way that it doesn't hog the entire bandwidth of your cluster. We want to run some other applications simultaneously. So these things are taken care of in the app template, which we are going to see. So in general, the app templates developed by DataTorrent are available on the URL datatorrent.com/apphub. So these app templates are nothing but ready-to-use customizable applications for big data ingestion use cases. And in future, we are going to have a lot more app templates which will solve different use cases. And you can look at the source code of these particular app templates. The URL is given over here. It is github.com/datatorrent/app templates. And this source code is open sourced under Apache 2.0. So you are free to fork it, clone it, download it, modify it, distribute it, and use it in your enterprise applications and stuff like that. So let's move on to the app template, which is of focus topic today. So we will be talking about HDFS to HDFS sync app template. So use cases for this app template are disaster recovery. So let's say if you have some source cluster where you maintain which is HDFS, and you are maintaining all your data onto that HDFS, and for disaster recovery purposes, you want to copy this entire HDFS directory on some remote HDFS. you can use this particular app template. Or another use case could be for archival purpose. Let's say if you have some particular directory which is of importance, maybe you want to take daily backup of that particular directory on some remote machine and stuff like that. So main features for this app template are firstly dynamic scaling. So if you have a large amount of data at your input, the application will scale out dynamically, and once that data is copied, the application will shrink down to minimal resources. And since it is built on top of Apache Apex, the fault tolerance comes built in. I mean, there is no code written in the application as such to handle the fault tolerance. If you look at the source code of the application, you will realize that because fault tolerance is taken care of by the engine. And it's easy to customize because source code is given over there. You can modify it and you can customize it to suit your requirements. So requirements could be like, I have the logs file coming in continuously, and maybe I want to, depending on the timestamp, maybe I want to collect all the log files generated during one particular hour into a single file. So the incoming files could be, let's say, few MBs each, but the target file would be, let's say 100 MB or 500 MB or stuff like that. Any questions till now? Okay, so there are no major questions as such, so we will move on to the next thing. So in Apache Apex, any application is represented as a directed acyclic graph. So when we talk about graph, we think of nodes, that is vertices and edges, right? So nodes in this case are the operators or the computational units, and edges are streams. So stream is nothing but a sequence of data tuples. So data tuples are flowing from one operator to another, and tuple is nothing but you can consider it as any Java object which is serializable and which has some specific schema associated with it. And operator is, in simple terminology, it's just a Java class which is implementing some interface and which defines how to process a particular tuple coming on a particular incoming stream. So let's have a look at the live demo, and during the live demo I will explain about some details about this application. So I have DataTorrent RTS installed on my machine, and let's move on to the App Hub tab. Then we can search over the application name. So we can see the listing of HDFS sync apps. So there are so many apps which are available under App Hub. So if I import this application, you can see the notification saying app has been imported. If we click on that, we can see the details about this app package, and it gives the launch button. If we click on the launch button, we can see the launch dialog box. So this app template comes with pre-configured configurations, pre-built configurations. So one of the configuration is for suitable for clusters, and other configuration is suitable for DataTorrent RTS sandbox, or if you are trying it on single node Hadoop installation, you can use the sandbox memory configuration. So for now I will select the cluster memory configuration, and then we have to specify some custom properties. So I will check on the specify custom properties, and then if we expand by clicking on add default properties button, it will show the properties editor. Now it is asking for the HDFS input module files. So basically we need to specify the input path. So I will just use some pre-saved value. So I'm basically trying to copy data from node 35, which is one HDFS cluster, from this particular directory user DTTBC, and there is some data set which is ingestion source data. And as a destination, I will use this path. So the property name says HDFS file copy module and output directory path. Okay, so we just configured what is my input and what is my output directory, right? And we are done. We are ready to launch this application. So there are many configurable properties, but we have given the same default values, and those are defined in these XMLs. And you can look at the source code to see what's happening behind the scene, but we want to give the ease of use to the end user, so we are trying to keep the minimal properties exposed to the user and trying to give the defaults to most of them. So let's launch this application. We can see a notification which says that this application has been successfully launched, and now if we click on this application ID, we can see the details for this particular application. The containers are getting allocated. So we can see the DAG, or the directed acyclic graph, for this particular application. So let's look at the details for this graph. So it consists of 1, 2, 3, 4, 5 operators as such. So 2 of them are part of the input side. So it says HDFS input module. Okay, so HDFS input module consists of 2 operators. One is file splitter and the other is block reader. So job of file splitter is basically to pull the input directory, scan for new files, and if there are new files found in this particular scan, you just emit metadata about those files. So we might say that, okay, I discovered new file which is of 1 GB, and it is the complete path for this particular file, it's so and so. The block reader reads this metadata. Now the file splitter will split whatever the 1 GB file, let's say, into chunks. So by default, the chunk size is same as the HDFS block size, so which is 128 MB by default. So it might say that, okay, I have 8 blocks to copy, so that information is passed on this port. The block reader reads each block independently. So file splitter in some sense is a very lightweight operator because it is just emitting metadata. So we can have single physical instance for file splitter, but block reader is actually reading data from remote HDFS. So we should have multiple partitions for block reader. So by default, for cluster configuration, we have configured it to be 16 partitions for block reader. So this operator will get partitioned into 16 instances, and then on the output side we have 3 different operators: the block writer, block synchronizer, and the file merger. So let's look at the functionality of each one of them. So once block reader has got the information saying that I have some block to read, it could say that, okay, for file 1 you read data from 128 MB to 256 MB. So that particular limit offset is given to block reader. Block reader will read that data and pass on that data to block writer. Block writer will write that data into some temporary file on HDFS, and it will send the signal to block synchronizer. The block synchronizer gets file metadata from file splitter. So it knows that for file 1, I'm expecting 8 blocks to come. Block synchronizer will basically maintain flags for each one of the individual blocks, and once all the blocks for a particular file have been received, it will send the trigger to the file merger saying that I have received all the blocks for this particular file, and you can now safely copy this file to the destination. Okay, so some of the audience members are saying that there is some audio issue. So can you just type in saying whether I'm audible or not? Okay, so I think for most of the members, audio looks fine. So we will continue. So yeah, so I was saying that so we get the trigger, the block synchronizer will send out the trigger and say that okay, I have received all the blocks for this particular file, and it is safe to copy this file to the destination. So file merger will do the job for copying this file to the destination. And in general, we have tuned this application to pull the data from remote HDFS to the host HDFS. So by that I mean, if I'm running this application on whatever, let's say the cluster belonging to node 21, and I will pull the data from some remote HDFS. So if you want to copy data into your Hadoop Lake, we would recommend that you run this particular application on the destination side rather than source side. Now let's look at the reason why. The reason being, if we run this application on the destination, the intermediate data which is written by this block writer is on HDFS, which is this AppFS, or the local file system, the host file system, or the host HDFS on which this app is running. And since that data is available on host HDFS, we can directly merge those individual blocks and create the file at the destination. So there is some optimization involved in it, and that is why we recommend to use this particular application such that you are pulling it from remote HDFS and getting it into the app FS, I mean the HDFS on which the app is running. Okay, so we covered the details about this particular directed acyclic graph. Now let's look at some other features. So we can see the operators involved are listed over here. So let's click on one of the operators, let's say file splitter. So here we can see the properties for this particular operator. So here we have specified what is my input files, and other properties have are taken up from the default values. So we are saying that my scan interval is 5000 milliseconds, and basically if you want to filter some file, let's say if you want to say that I just want to collect files which are .log extension, then we can use this particular property, but we are setting it to null by default, so we'll list all the files. And there is a property which says that whether you want to copy recursively, which is equivalent of cp minus r, and we are setting default as true. So these are pre-configured. So this is the logical operator, and we can see the container given over here. So if we click on this particular link, it will move to the container page and it shows a link for logs. So we can actually see the container logs within the browser. We don't have to SSH and look around for debugging. As we can see, we have 16 partitions for the reader as well as for writer, and for others we have just a single partition. And writer, we can see one more container allocated to it, and the reason behind that is engine introduces something called as unifier in between. So since this has 16 partitions and downstream operator has a single partition, it has to combine all these 16 stream into a single stream, and application developer doesn't have to worry about it. Platform will introduce the unifier in between by default. So here we can see the physical view of the application. We can see individual containers over here. We can see the latencies involved for individual tuples, and we can see total number of tuples emitted per container, or we can see total number of tuples processed per second and stuff like that. And we can see the allocated memory for this particular application. So this is you can see the physical DAG of this particular application looks like this, because we have 16 partitions, and then all of them are coming to the single downstream operator. So this is the unifier, and this is the synchronizer, and this is the file merger. So if we scroll around, you will see this complex application, and this is the actual parallelism achieved using the platform. And if we look at the source code for this particular application, it's hardly a few lines of code. So what I want to highlight is most of the things are taken care of by the platform. So here I have just defined saying that I want to use file system input module, so we call it as a test input module, and file copy module at the output, and connect it using the streams. So I will connect the stream for file metadata, block metadata, and blocks data. And since this blocks data stream, which is from reader to writer, is very heavy, this particular stream, which is actually transferring the data, is very data intensive, we connect it using thread local. So both the operators will get deployed on the same container and gets connected to a single thread, so that the performance is optimized. So hardly, you can say, 5 lines of code, and we get all the things taken care of by the platform. So the fault tolerance is taken care of by the platform, the scalability is taken care of by the platform. So let's have the demo about the fault tolerance. So I'm going to kill one of the containers, but in reality it will be like your container will get killed because of some exception. It could be because of network failure or disk failure or null pointer exception and whatnot. But some exception will lead to container failure, but we'll just simulate that using this kill functionality. So I will just go to this particular container and just say kill. So this container is killed. But if we look at the application, the other containers are still in active mode, and you must have received this killed container, and that might have got redeployed on some other machine. So let's try to do it one more time, and this time we will kill something from so we will kill the first operator, the file splitter itself, and let's see what happens. So this is now killed, and as you can see, all the containers were in pending deploy state for some time, and then they became active. The reason is because the downstream operators are dependent on the upstream operators. So if there is some error in the upstream operator, the downstream operator has to reset to some point in time and then start again. But they won't start from zero or start from scratch. They will start from something called as last checkpointed state. So we maintain periodic checkpoints of the applications or of the operator states. So by that I mean, if you have some variables in your operator, we will take the values of those variables, serialize that particular object, and save it on HDFS. And this happens behind the scene by the platform. The app developer doesn't have to write single line of code for this checkpointing mechanism, recovery mechanism. This is taken care of by the platform. And the application will get recovered from the last checkpointed state. So we looked at the scalability part, we looked at the fault tolerance part. That's the main thing I wanted to highlight in this particular app template. So we looked at the live demo. So if you have any questions, you can take them now. So Mohit, any specific questions to be discussed on the audio?
So there is one question about answer to that. So there's a comparison with DistCP. So how is this different from DistCP? This particular app template.
Okay, so DistCP actually I think is based on the MapReduce, and it will invoke one job for each file. But if you have a single big file or large number of small files, and if you want to handle both of them, then it's difficult to do it using DistCP. But in this case, if you have large number of small files, the file splitting and block reader mechanism will take care of that. You don't have to run multiple small jobs. When you run multiple small jobs, the overhead of scheduling the job is more than actually copying the data. Whereas in this case, once the operators are deployed, they will remain over there for the lifetime of the application. So if you have continuous incoming data, those operators will remain over there and they will just copy the data on the fly as it comes in. Whereas in case of DistCP, it will try to schedule new job for each new file.
So there is a question from the audience. What happens if the unifier is killed?
Okay, so if the unifier is killed, a unifier is treated as yet another operator, but which is introduced by the platform. So if unifier is killed, again the downstream operators will get redeployed, and they will be reset to the last checkpointed state, and the DAC sub DAC for that particular downstream will start from the last checkpointed state.
Okay. There's another question. We should also repeat the question. Is the container that we've shown owned by DataTorrent or any community version is available to use?
So actually, I'm not sure about what the container are you referring to, but when we say container, it's yarn container, or in other words, it's JVM container. So it's just a JVM, and if you are referring to the user interface which I showed on the web browser, that is part of the DataTorrent RTS. But there is a community edition for DataTorrent RTS which has limited functionality, and we also have a trial license for DataTorrent RTS which is for limited period with full-fledged functionality, and we also have a startup program for DataTorrent RTS which has certain criteria based on the size of your organization. You can get the full-fledged license of DataTorrent as for free.
Okay, Yogi, it seems like we're having some issues with the audio. Some people are complaining about it. So let's try again. There's another question. Let's repeat the question. This is from Ellis Wong. The question is, does this Kafka HDFS platform require any hypervisor to run as containers within VM instances?
So within VM instances, I would say if you have virtual machines, and if you have set up a Hadoop cluster on top of those virtual machines, the yarn which is controlling the Hadoop will take care of the containers. So we are not having any specialized containers as such. Uh, our containers are just yarn native containers. So those are the JVMs which we are using. Okay, if you have any other questions, you can just type in the questions panel. We can see some questions popping up on the panel, and we can take the questions which are of interest for the wide audience over the audio. Otherwise, we'll give just type in the answers for your questions if they are too specific. But let the questions keep coming in. So, by the way, that's all I had from the presentation perspective. So, this is the resources slide which gives the important links about our platform or DataTorrent RTS. So, basically, you can go through the Apache Apex website, or you can subscribe to our forums. So, we have link for community. So, we have uh, Apache mailing list for Apache Apex, both for developers and users. There is a separate mailing list, and we have a dedicated Google group for DataTorrent RTS users. So if you have any questions which are specific to these app templates, you can refer to these Google groups and write to us. And we would definitely love to hear the feedback from you guys. And you can download the DataTorrent RTS. So there are different licenses. As I said, we have a community license, and we have trial license, and we have a startup accelerator, which is explained over this link. And there is a sandbox edition available, which comes with a VirtualBox direct trial image, which you can just import in VirtualBox and try it on your own. So you don't have to do any Hadoop installation and stuff like that. And you can follow our Twitter handlers for DataTorrent and Apache FX. And you can join the meetup channels, which have Apache Apex topics. And we have a very widespread presence over the meetup throughout the world. And there is wide content available on the YouTube. So the archival of all our previous webinars and meetups are available under this channel, DataTorrent channel on YouTube. And the slide decks for this particular presentation and all our previous presentations are uploaded on the SlideShare under DataTorrent handle. And for more app templates, you can look at this datatorrent.com/app link. So I would say this link is the key takeaway for this particular presentation. So if you remember this URL, you can just explore it on your own in the next few days. And there are demo videos and the walkthrough videos and walkthrough documents available on those pages for respective app templates. Thank you. If you have any questions, you can still type in the question panel, and we will be happy to answer them.
So I think there is a general question from the crowd with respect to the video and the slide deck.
The videos will be uploaded to YouTube, and slide deck will be uploaded to SlideShare DataTorrent handle. And just give us 1 or 2 days, and we will just make them available on those channels. So the actual links will be, you just have to go to. So this is the link for SlideShare, and this is the link for YouTube. So you can see all the archives till now, and even this particular recording and this particular slide deck, you can expect it to be on these links within 2 days. Okay, so we will wait for a couple of minutes. If you have any more questions, you can just type them in. And those who are done with the questions can leave the webinar.
There is a particular question about certification. On the website, there is a link.
Okay, so there is one question regarding the certification about Apache Apex or DataTorrent. So for that, we do take the certifications for corporates, and if your organization is interested in conducting the training sessions or certification for the employees in your organization, we will be happy to take that, and the link for that is available on the website of datatorrent.com. Okay, so I think we have answered most of the questions. So if there are no more questions, we'll just say final thank you.
Hello everyone. This is in continuation with this webinar series. There are more such webinars that we will be presenting for different kind of other application templates. So please stay tuned. Please do check out on our webinar site for further details. And the YouTube video and the slide will be available soon. We'll send out the links as well. So please stay tuned, and thank you all for your participation today, and thank you for all the questions and the patience. Our apologies if some people were not able to hear us out clearly. We tried whatever was best from our side that we could do, but the videos and the slides would be available. And if people are interested in contributing to Apex, please do subscribe to our user forum, where you could check out our code, comment what you think could be next in feature into the platform. Thank you all. Thank you.